everyone. In this video, we are going to work on the MCQs question based on the topic tree and associated terminologies in a graph theory. The first question is, which of the following statement is true about a tree? Now, what do you mean by tree? Tree is basically an undirected graph that is connected and there is a no cycle present in that graph. Such graph is called as the tree. First option says that it always contains a cycle. No, as per the definition, tree does not have any cycle. The next is the number of vertices is equal to the number of edges. That is also incorrect because if we have any tree with n vertices, in this case, always edges are n minus 1. So count cannot be equal. It is a connected, yes. It is a acyclic. Acyclic means no cycle in a graph. Yes. So as per this, option C is correct. What about the D? Every vertex has a degree 2? No. We can take a graph of this form and check it whether it is a tree. Yes, because it is a connected and it is a no cycle. Moreover, the degree of these three vertices is 1 and this vertex has a degree 3. It means every vertex is not of the degree 2. Hence, option D is also incorrect. Next case, a leaf or a pendant vertices in a tree is a vertex with degree 0, with 1, with 2, or a vertex connected to all other vertices. Leaf or pendant vertex means degree of the vertex is 1. If the degree of any vertex is 0, that is called as a isolated, but that will not be a part of a tree because tree is connected graph. Next is, if a connected graph has n vertices, m edges, then the number of edges in a spanning tree. Now suppose we have any graph, we can obtain a spanning tree. Spanning tree means we need to find a tree from the given graph and it must contain all the vertices of the graph. That is called as a spanning tree. Now, how many edges are there in a spanning tree? Whenever there is a part of a tree form, in that case, if we have n vertices, clearly it has n minus 1 edges, either a simple tree or a spanning tree or a minimum spanning tree. So always remember, in a tree with the n vertices, it contains n minus 1 edges. Next, Kruskal algorithm is a type of. Remember that Kruskal algorithm is used to find the minimum spanning tree and this algorithm is a greedy algorithm. Next, in a binary tree, the in-order traversal sequence is what? What is a binary tree? Binary tree means every internal vertex has two children. And in-order traversal. Basically, there are three traversal. One is called as a pre-order, second is in-order, and third is post-order. So what is the difference between these three one? In pre-order, first we visit at the root and then left, then right. Whereas in order, first we visit at the left, then root, then right. In post order, left, right, root. Based on the position of root, we have pre-order, in-order and post-order. Pre means firstly visit at the root. In means in between. Post means after that one. But the sequence of left and right is same. First we need to visit at the left and then right. As per this question, we need to find the in-order sequential, that is left, root, right, and that is in the option B. Next is, which traversal method visit the root first, then left subtree, then right subtree. Root first means it is a pre-order. A connected undirected graph has 8 vertices, 14 edges. Then how many edges will be there in a spanning tree? It is very simple. If we have 8 vertices, first we need to construct the spanning tree. Spanning tree contains the same count of vertices. Now, if there are 8 vertices in a tree, how many edges in that case? That is a 8 minus 1, that is equal to 7 edges in a tree, always. Hence, option B is correct. How many different spanning trees are possible in a complete graph of 5 vertices? For this, there is a basically one result that is called as the Kelly's formula. It states that the number of spanning trees in complete graph Kn is always n raised to power n minus 2. According to this, we need to find the spanning tree possible for the complete graph with 5 vertices. It means the value of n is 5. Plug value 5 here. So 5 raised to power 5 minus 2, that is equal to 5 raised to power 3. This is equal to 125. Hence option A is correct. Next, what is the height of binary tree with a single node? Suppose we have any tree that contain only one node, and one node means it say that only root. What is the height of this tree? Remember that the label starts from 0 in the tree. So root is always at the level 0. Now maximum level, that is also 0. Hence option A is correct. Next, a minimum spanning tree of the graph is a minimum subgraph? Yes, because when you construct a spanning tree from the graph, that will be the subgraph of the graph. Is minimal. Minimal means overall weight is minimum. So option A and B both are correct. That is mentioned in a C. Next, how many vertices are there in a tree with the 6 edges? So if we have n vertices, then total number of edges in that case is n minus 1 in a case of tree. Now the edges count is given to us, that is 6. Now what is the value of n in this case? That is the 7. So total vertices are 7. Which of the following true for the emery tree? Now there is a two terms. One is called emery tree. Second is called as a full emery tree. Emery tree means every internal vertex, not for every vertex. We just call for the every internal vertex has not more than m children. That is the correct option. And if we say exactly m children, it means it is a full embryonic tree. What about the last option? Every internal vertices has at least m children, means minimum m children. That is incorrect. It says that it can be have more than m children. Hence, D option is also incorrect. Only B option is correct. Next, how many vertices of full 5 tree with the 3 internal vertices have? Remember, there is two important formulas in full emery tree. If we have any full emery tree, number of vertices is equal to internal vertices into m plus 1, whereas number of vertices is equal to leaves plus internal vertices. With the help of these two formulas, we can answer the terms internal vertices and leaves. Like in this case, the value of m is given to us, that is 5. Count of internal vertices is 3 plus 1, that will give you the total number of vertices that is represented by n. So here we have 16. Next, how many leaves a full 3-array tree with the 5 internal vertices? Now the question is not about the vertices, it is about the leaves. As per this, we have m is equal to 3 and the internal vertices is equal to 5. Now we can use these two formulas to calculate the leaves. From the second formula, leaves is equal to number of vertices minus internal vertices. Now how to calculate the number of vertices? We can use this formula. Number of internal vertices into m plus 1. This is equal to 3 into 5 plus 1, 16. Now leaves is equal to 16 minus 5, that is equal to 11. Hence option B is correct. Next question we have, if we have full binary tree with the 100 leaves, then the number of edges in a tree is equal to what? Now whatever the data we have, let's collect that one. Full binary tree, it means full 2 tree. According to this, m is equal to 2. 100 leaves means the value of L is equal to 100. Now we need to calculate how many edges in a tree we have. We know that edge count is always is equal to n minus 1, where n represents the number of vertices. So with the help of the given data, can we calculate the number of vertices? Yes. Remember that formula? N is equal to I into m plus 1 and n is equal to leaves plus internal vertices. From here we can extract the value of internal vertices because we don't need that. That is equal to n minus leaves. Plug here. N is equal to n minus L into m plus 1. Now plug the values. This is n minus 100 into 2 plus 1. Simplify this. This is n is equal to 2 times of n minus 200 plus 1. That is equal to minus n is equal to minus 199. Simplify this. N is equal to 199 and hence the number of edges is equal to 198. Taking the next case, what is the value of prefix expression? Prefix expression means it is a traversed in form of pre-order. In pre-order, we have root first, then left, then right. And whenever we have this expression, you need to remember one more thing. In root, we always take as an operator and left right is always act as the constant or a variable. Right now there exists no variable and we need to evaluate this expression. It means we deal with the constant. So in case we have operator constant form, we will operate that. How to operate? We will treat it as the constant operator constant. Let's try to implement this concept here. So here we need to find operator constant together. That is available here as well as here and here because operator constant. Same in this case, operator constant, operator constant. Now what does this arrow represent? Arrow represents the power. How to evaluate this? This is 3 raised to power 2. What does it mean? This is 3 raised to power 2. According to this, this is 2 raised to power 3. And in this case, 4 minus 2. Evaluate this. This is equal to 9. Here, 8. Here, 2. Take the rest of the things as it is here. That is plus minus as it is. We have evaluated these terms. This divide 6 as it is. Now again evaluate the point operator constant. That is here as well as here. For this it is a 9 minus 8. So we can write plus as it is 9 minus 8. In this case 6 divides 2. This is equal to plus 1. 6 divided by 2. Final answer is 3. Now again we get this form operator constant. So plus 1 3 that is equal to 1 plus 3 that is equal to 4. Hence option C is correct. So remember in a prefix expression we have root first, then left, then right. Root is always operator, left rights are always constant. And if it is a postfix, in that case we have left, right, then root. And the root is always operator. And in this case we have the form constant operator. Next, the height of below rooted tree is what? How to calculate the height? First we will calculate the level of each vertex. As in this case, the root is given to us as a. Root is always at the level 0. Next, these 3 vertices are at the level 1. These 4 vertices are at the level 2. These all vertices are at the level 3 and the last vertex n is at the level 4. Maximum level of the ordered rooted tree that gives you the height. So according to this, height of this tree is 4. Next, which of the rooted trees shown below is balanced? Balanced means if leaves of the tree are at level h or h minus 1. So it means first need to calculate the level and then height. According to the tree 1, level of this vertex is 0. These are placed at the 1, these are at the 2 and these are at the 3. Now highest level is 3. It means the height of this tree is 3. Now what do you mean by leaves? Leaves means a vertex that has no further child. Or we can say that whose degree is 1. So its degree is 1, its degree is 1. So these all are the leaves. They are placed at the level 3. Even these two vertices are placed at the level 3. So it means at the level h. Now these two vertices are placed at the level h minus 1, that is 2. So there exists no other leaves. It means all the leaves are at the level 3 or 2 and hence it is a balanced. Now what about the second tree? T2, level 0, level 1, level 2, level 3, level 4. Now leaves are present at the level 4, at the 3 and even at the 2. So it means this tree is not balanced, as we say that leaves of the tree must be at the level h or h minus 1, not at h minus 2. Here height is 4. So leaf must be present at the level 3 or 4. But if we are getting any leaf that is present at the level 1 or 2, it means that tree is not balanced. What about the third case, T3? So leaves are at the bottoms. Here we have another leaf that is one previous to this height. So hence it is also balanced. So it means T1 and T3 are the balanced tree. Next, a binary tree has n greater than equal to 1 leaf node. The number of nodes of degree 2 in tree is what? First, take any picture of tree in your mind. Let's suppose I have taken this one. In this case, degree of this vertex is 2. Degree of this vertex is 1. Degree of this vertex is 3. Here, 1, 1. Now, how many vertices we have with the degree 2? Because we need to find the vertices of the degree 2. That is only root. Now, according to this, it is a binary tree. Is this a binary tree? Yes, because every internal vertex has a 2 children. Now, is leaf is greater than 1? Yes, because we have 3 leaves in this case. Let's take another case of binary tree. This total number of leaves is greater than 1, that is 2. Now, how many vertices are there with the degree 2? That is only root. So, answer in this case is always there exists a one root whose degree is 2 in case of binary tree. Otherwise, the vertices degree is either 1, that is called as a leaves, or 3, that is for the internal vertex except root. So the count is always 1, hence option D is correct. Taking the next case, the number of leaves in every tree of the height h is what? Remember that the number of leaves in every tree is always less than equal to m raised to power h. According to this, when we say less than equal to m raised to power h, it means L is at the most m raised to power h. So according to this, option C is correct. Next, which of these graphs are tree? Tree means it is a connected, undirected, and there exists no cycle. According to this, A does not contain any cycle. Moreover, it is a connected. For the case B, it is a disconnected because from this vertex we cannot reach to any of these three vertices. So it means B is not the tree. What about the C? So this is a connected? Yes. Is this contain any circuit? No. Because the vertices are representing here, but this is the intersection of the edges. So it is not creating any kind of circuit. So hence C is also a tree. What about the D? No, because we are getting a circuit in this case. Hence option A is correct, which say that A and C are the trees. Next is, in a pre-ordered traversal, the first thing is processed is what? That is always root, because it is a pre-order, first as a root, then left, then right. Next is, if the height of the tree is 10, then what is the highest level of the tree? Height itself means maximum level. It means the maximum level of the tree is 10. Next, let T is a binary tree of the order 71, then the number of pendant vertices in a tree is what? Now it is a binary tree, means the value of m is equal to 2. If we say order means the number of vertices. So it means the number of vertices in a tree is 71. Now how many pendant vertices? Pendant vertices means degree is 1. Now whose degree is 1? That is of the leaves. So we need to count what is the leaves in the binary tree with the total number of vertices 71. Recall that two results, n is equal to m into I plus 1 and n is equal to internal vertices plus leaves. According to this, 71 is equal to m is 2 into I plus 1. Evaluate the internal vertices. Internal vertices we have 71 minus 1 by 2, that is equal to 35. So leaves we have 71 minus 35 is equal to leaves, that is equal to 36. Next question, if T is a tree having a 20 vertices, then the maximum possible sum of the degree of all vertices in a tree. Simple concept is there. Total number of vertices we have 20. As per the requirement, we need to find the maximum sum of degree of all the vertices. Now, if we have n vertices as a 20, then how many edges we have? Total edges in this case is 19. And we know that total degree of the graph is equal to 2 times of number of edges by the handshaking theorem. Total edges are 19. So 19 into 2, that is equal to 38. Hence B option is correct. The last question is, let K is a chromatic number of the graph and T represents the tree of the order n. Means the number of vertices in a graph is equal to n as well as in a tree. Then which of the following is most appropriate option? It says that the chromatic number of a tree is equal to 2 or 1 or is equal to n or less than equal to 2. How to answer this question? We can randomly take a tree in this case. Let's suppose we have this tree. In this tree, we can color this vertex as a pink, but we cannot color these two vertices as a pink. Whereas we can give pink to these two vertices because they are not adjacent with the root. And here we can give the same color to these two vertices because they are not adjacent. Right now the color is 2. Clearly C option is incorrect. Even B option is incorrect. Now either the answer is A or at D. If you construct any tree with more than one node, definitely the chromatic number is 2. But there is an exceptional case. Suppose we have a tree that consists of one single node. Total number of color used in this case is 1. So overall we can say that chromatic number is always less than equal to 2. It can be 1 or maximum as a